All right, guys, in this segment, we are there. We are about to cover the final and what I consider the ultimate level of logic for this unit. So I'm super excited. Once we finish this issue of full electron configuration, then we will go into a significant amount of review to get you ready for the test. So you're going to see plenty of different question types. I'm also going to talk to you about ways that you can change the questions to try to predict what I'm going to be asking you on the actual exam. So like usual, I don't want to spend too much time. I think the best thing that we can do is jump right in and get started. So what we're talking about today is electron configuration. Now, electron configuration brings all three pieces of the quantum mechanics, the mathematics of quantum mechanics together. So you're going to deal with principal quantum number, magnetic quantum number, and magnetic spin. Okay, and all of those things come together to tell us the shape of the element, and ultimately it is the math that describes the identity of the element. Now for us it's way simpler because now we have a periodic table and we know that we have the S tower that starts on the first floor, the P tower that's on the second floor, the D tower that starts on the third floor, and down here is the F tower. All of this that we've done is the quantum mechanics. Okay, so I don't want you to think that I'm teaching you something different. All I'm going to do is add a layer. So I have a periodic table. If you use the one that's online, that's fine. I have the new notes, and we're going to kind of play with this just to get us to the answers to last time's homework assignment. So I'm actually going to use these very same practice problems to help us get started with electron configuration. Okay, so if you need to get the answer key to these, you're about to get it right now. So let's start with this brief note on electron configuration, which says that we must account for every electron in order until we reach our desired element. And so first I want to apologize because this is going to be a little bit of work, not complicated work, but you'll see it starts to get redundant. It'll get easier, but you will have to write out extensive calculation. So let me just show you. Using the element helium. So I'll also use this as an opportunity to do a little bit of review. If you remember He for helium, then you should know how to create a element tile. And the element tile has two numbers, one on top and one that's on bottom. Take a moment and think about those two. See if you can remember. So for helium, the number that's on top is what we call the atomic number. It's also the number that's on my periodic table on top as well. When you look at the periodic table, you'll see that helium has an atomic number of 2. The bottom number is the atomic mass, and that number is 4. Okay, so this is one thing. Do you know the atomic number? Do you know the atomic mass? Can you use those two numbers to tell me how many protons, how many neutrons, how many electrons? What's the atomic mass? What's the atomic number? And then we can play with issues of charge. Next, we deal with Bohr atomic model. Can you draw me the model for this? And what I've shown you is that we have a nucleus in the center, and this nucleus has 2 protons and how many neutrons? It has 2 neutrons. Then what you do is you add your first energy level, which we draw as a circle. Okay. And then we start filling in the electrons. And in this case, because we already know that the first energy level can hold a maximum of 2 electrons, we put those 2 here on the right. This is the Bohr model. Simple, right? Next, the notation. So when we do the final electron configuration notation, the answer is 1s2. And so I want to explain each of these. So first, each of these represents a piece of the quantum mechanics calculation. Okay, this 1 tells us where 1 is the energy level. AKA principal quantum number. Okay. Then S. S is also part of this calculation, and this one is the block. I've also called it a tower from time to time, but the block is more accurate, or also known as the magnetic quantum number. And finally, the little 2. Okay, when it's high or up in the up position, we call that superscript. So this is a superscript 2. And this is the number of electrons in the block. Okay, aka magnetic spin number. Okay, so I give you the very technical terms. It is important that you get comfortable with these technical terms. Okay, so it is called the energy level, but they might also call it principal quantum number. I don't know. So you got to be comfortable with both of these terms, okay, for all of 1s2. Okay, with that being said, I think, like I said, it's just best to take this. Now, hopefully you're familiar with 1s. And now I'm just going to explain this, and we're just going to do practice, practice, practice. So I have this now, my periodic table, as well as this, your previous practice problems. Notice I haven't filled any in because we're going to fill them all in right now. Let's start here with lithium. Now, we've already established that lithium is in the S tower. It is on the second floor of the S tower. The question that we're asking is, how many apartments down the hallway did you have to go to get to lithium's apartment? And in this case, you only had to go one apartment down, and so this is called 2s1. Okay? These are practice problems. Let's go on down to calcium. Okay, calcium is over here. And how many did you go down? So we know it's 4s, 1, 2, 3, fourth floor of the S tower. And how many apartments over is it? 2. So we put 4s, 2. Dog, that's it. Let's go over to carbon. First of all, we say that carbon is on the 2p floor. And the reason we say that is because it's in the p block. And remember, the p block starts on the second floor. Then the question is, how many apartments over did we go? Well, 1, 2. We had to go down 2 apartments. So this is 2p, 2. And then BR, let's take a look down here at BR, which is number 35 on your periodic table. Remember how we count. We find the block, which is the p block. We count how many floors down we went. 2, 3, 4. So it's 4p. And then how many apartments over did we go down the hallway? 1, 2, 3, 4, 5. So this is 4p5, okay? So I'm going to run through the next ones a little bit quicker, I hope. So this is 4s1. V, okay, here, this is 3d3. Sn is over here somewhere, okay? This one is 5p2. We went down 2 apartments. And then FR here is 7s1. Let's go on to these. NH, boy, 7p. So that means it's in the p block. Let's see. 7, 2, 3, 4, 5, 6, 7. Okay. And NH is here, the first one on the hallway. So this is 7p1. Uranium is down here. Okay. So now we're talking about, remember, the F tower starts on the F block starts on the 4th floor. So this is the 4th and this is the 5th floor. So this is 5F, 1, 2, 3, 4, 5F4. AU, which is here. Now, AU is a bit special, right? Because for AU, actually, this one, yeah, here's the thing. This one counts as an apartment. And technically, this slot 71 is down here, 71, okay? So this does exist. And I probably, to be honest, I probably should have colored these two green just to be super clear. These two green. All right. So AU is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's the 9th one over 5D9. Now, I'm glad this came up so that you know that you will count this slot because its apartment does exist. All right. Next is F fluorine, that's over here, which is 1, 2, 3, 4, 1, 2, 3, 4, 5, the 5th one over. 5. All right. So listen, guys, I've gone over these, and now what I want to do is take a moment, and I'm going to give you all of these answers, okay? And so what I want to do is make sure that you get your own answers first. Build up your confidence using these, okay? So I'm going to do it in 2 sets. I haven't even touched this in my answer review. So the first thing I'm going to do is review this answer. I'll give you a chance. I'll show you the answers, and then I'll go column by column, giving each set out until we finish up on the pick your own, which obviously I can't do. You're going to have to do your own. Okay, so let's give it a try. So I'll give you these first answers. Here we go. In 3, 2, pause it if you need to. 1. Bam, here we go. So these are the answers to the first set. Hopefully you got them right. If not, take a moment, examine them, and then let's move on to the second set. So that set would be down here. Let's see if we can get it all in the camera. Okay, good. From CA to CM. All right. Remember, principal quantum number, magnetic quantum number, and magnetic spin number. Here we go. 3, 2, 1. Pow. All right, here we go. You have your answers here for all of this set. Make sure that you have this set clean and confident. Take whatever lessons you've learned from your previous mistakes, clean it up before I reveal these answers in 3, 2, 1. All right. So here are the answers to the second set. This one on hydrogen is 1s1 in case that camera's cut off. But I wanted to come down here to the bottom because these are the ones that I think might get you tripped up. And you never know, I might ask about these. So let's find PM. PM is here, okay? One mistake that I don't want you to make is counting this. Remember, these are just markers, okay? So the D block has 10. This one is 71. Okay, so 71 actually goes in this slot. 71, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 across. The F has 14. Okay, 56. This is 57. Okay, 57 all the way up to 70. That's 14. And then this one actually goes in this slot. Okay, so with that being said, PM is 4F. We know it's in the F block. It's the 4th floor. But how many over? Remember, we don't count this, so it's 1, 2, 3, 4, 5. 4F5, and then TM is 4F13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is this one. And remember, F has 14 total. These two fit over here in this slot where the stars are. Okay, so that's 4F13. All right, guys, so this would be my last chance, the last opportunity I have to help build your strength and your confidence in doing the what I call the valence electron configuration. And then we will talk about the full electron configuration, which you'll see now that you know how to do this. Really doesn't take too much time. So I'm going to give out the answer in 3, 2, 1. All right, we have done it. So the top one, in case my camera's not looking good, americium is 5F7, and down here silicon is 3P2. Okay, everything else you should be able to get and check on your own. All right, guys, listen, we have done it. I really do hope that after all of this review, your confidence is high, you're sure, and you can even say that this is easy, because that brings us to the last piece, which is this one. Now, once again, I'm only going to give you part of the answers and expect you to take it all the way home.